Avon High School, ACE College Algebra 2 students, Mr. Record here, and you're looking at the first of a couple of videos in a series that coincide with our unit number 9, this one covering section 3. The title or the objective is to graphically understand what domain and range values of a function represent, and then to kind of, reflect on that both graphically and analytically. But maybe another way to think about this particular section is how to perform some computations that involve function notation. So my first part of this video, I hope to get through examples 1 and 2, and then in the second video, I'll finish out the notes that will take care of examples 3 and 4. So a lot of the stuff here up front is going to look a little familiar to you. We talk about this notation, f of x. It's read as f of x. It's a notation of a function that actually means the same thing as y. So if we consider some function, as you see here, anytime that you're asked to find the following function values, you probably have remembered that you just simply plug in the value for the x. So f of negative 4 is just a matter of replacing the x with negative 4, like such, and then just being very careful as to not make some kind of a silly mistake. Follow the order of operations, so do what's in the parentheses first. And when you square negative 1, we would just get positive 1, of course. And by the time we get to 2 times 1 plus 4, we'll get 6. You might find that I might scamper through a lot of these examples fairly quickly. If you find that I'm going a little too fast, you can always pause the video as you're completing your notes and then resume them when you're ready. So for example 1 part B, same idea, using really good function notation. I want to kind of declare what it is that I'm doing. F of negative 1 in this case. We would take the negative 1, plug it in for the x, and then being very careful so as to not make some kind of mistake. Negative 1 plus 3 is positive 2. Positive 2 squared is positive 4. And then when we have negative 8 plus 4, that results in a result of negative 4. We'll do one more. Again, I'm going to assume that you all think that this is pretty easy, but it's going to be a very common thing that you're going to do throughout the rest of your mathematics, both here and in college perhaps. So when we square the 3, we get 9, of course, and then negative 18 plus 4 would be negative 14. Now, when we found the value f of negative 4, the value of x was our negative 4, of course, and it asks, well, what does the result of f of negative 4 represent graphically? Well, graphically, that simply means that the y value is f of negative 4, or in the case here, 6, because f of negative 4 was 6, whenever x was negative 4. So just as you probably thought, it pretty much means that the point negative 4 comma 6 lies on your graph. Function notation is really nice. If we didn't have this, if this thing here didn't exist, then the directions of this problem would be a lot more wordy. They would probably say something like, find the value of y when the value of x is equal to negative 4. So we really use this as a nice shortcut. So the graph of f of x is pictured to the right. And it asks, do the results of f of negative 4 and f of negative 1 that you calculated above make sense in the context of the graph? Okay, well, f of negative 4, remember, was going to be positive 6, right? And f of negative 1 is supposed to be negative 4. Now, does that mean that I made a mistake? Does the f of negative 4 look like it is positive 6? Well, if I look up here, did I make a mistake? I plugged in negative 4 for x, added 3, got the negative 1, But yep, you can see in typical fashion, Mr. Record makes a mistake, right? So if we go back up here to part A, some of you found it. So you'd have a minus there, a minus there. So really, I should have had negative 2 times 1, which is negative 2 plus 4, which gives me positive 2. Okay, let's look back at this graph. If I look back at this graph, when x is negative 4, I should have gotten a positive 2. Okay, well, I do have to make a slight adjustment here, and I'll make that same adjustment here. Now, I hope you're not frustrated by that, because yes, I did that on purpose. I did that on purpose because a lot of times, if you have to rely on a table of values or sort of a t-chart to generate a graph, you might find that the other points on your graph are behaving the way that they should, but you would have this strange oddball point, which I think that would have been right about there. That just doesn't seem to make any sense. So that means that you could probably go back and readjust that particular value. All right, but it's very important to be very careful. All right, I was focusing so much on telling you guys and drawing your attention to not making a mistake with the operations that you saw, where I just made a silly mistake of recopying a negative incorrectly and turning it into a positive. Okay, so we're not going to really explain why. Basically, the points lie where they should, and everything is going well. Now, for some reason, we didn't want to talk so much about f of 0 in this explanation, and I think I know why, because f of 0 is supposed to be way down here at negative 14, and it's very likely that that indeed is going to happen if we were able to extend that part of the parabola. All right, let's talk zeros. Remember from Algebra 2 what a zero of a function is? Define that term below. What is a zero? Well, you could say a lot of things. You know, a zero of f of x is basically a value of x when the function f of x is equal to 0, right? That's pretty much where it gets its name. But another way to think about it, it's also where f of x crosses the x-axis. And I know that this is old hat. You've heard this many, many, many times. But I don't want to take any chances. I want you guys knowing this backwards and forwards. And it says that the graph of f of x clearly does cross the x-axis. And it does so at some value between negative 4 and negative 1. Somewhere right about here, let's say. Based on your computations above, how could you justify the guarantee of this occurring at some value between negative 4 and negative 1? So in other words, if we go back up here, what is it about the answer that we got for f of negative 4 and f of negative 1 that says that this graph would have to cross the x-axis? Think about that for a second. Hopefully, you come to the conclusion it's because these two numbers have different signs. If these two numbers have different signs, then there's no way that this graph couldn't cross the x-axis. It has to have a value equal to 0 at some point, because this graph is nice and continuous. Turns out that that's a very powerful theorem in calculus. It's called the intermediate value theorem. Okay? So basically, if it asks how could you justify or how could you guarantee, we'll just simply say, use a different color here, we'll say it's truly because f of negative 4 and f of negative 1 have opposite signs. Now, there actually are a few other things that one would have to say if this were a calculus class, like this function is also continuous. But for right now, that's about the only kind of functions that we've studied. That's going to change here in the next few days in this particular unit. Okay, hopefully that takes care of the first page there for you. So we'll slip over here to the second page. And it says, based on that graph, we cannot determine exactly what the zeros of the function are. Okay, I've got that graph sort of recreated here on this page for you. According to the graph, between what pairs of x value do the zeros of the function lie? Well, it doesn't matter which order you write these in, but I see that one of the zeros lies somewhere between negative 5 and negative 4. And then the other 0 lies between, and we can do a little bit better than saying between negative 4 and negative 1. We can pop this negative 2 out here and say it lies between negative 2 and negative 1. Now on the previous page it says we took this function, the same f of x function, and we found values of y by substituting in values of x. Now suppose we set the function f of x equal to some other number, call it a, and we solve for x. Now when you solve the equation f of x equal to 0, what do the results for x represent graphically? Well, we've already mentioned that. They represent the x-intercepts, right, where the graph will cross the x-axis. Now it asks us to state those values of x. So let's try it. So we're going to take this negative 2 quantity x plus 3 squared plus 4, and we're going to set this equal to 0. We're going to see how this goes. So let's follow the order of operations. The very first thing that we would want to do is subtract 4 to the other side. Pretty easily done. And then our next step would be to divide by the negative 2 that's out in front. Another pretty easy step. Now you're going to incorporate a step that we talked quite a bit about last semester. You're going to take the square root of both sides, and upon doing so, you are obligated to use the plus or minus of the answer to the right. X plus 3 would either be equal to positive square root of 2 or negative square root of 2. You can probably understand now why there are ugly answers. Now if we subtract 3, x would end up equaling negative 3 plus or minus the square root of 2. And we want to interpret that as being two different answers. That's very important that we think that way. 3 plus square root of 2, 3 minus square root of 2. If you think about it a little bit, which one would signify the left intersection? Well, that would be negative 3, minus the square root of 2. And this one would be the larger of the two, which is negative 3 plus the square root of 2. Now, I'm going to switch over to a calculator mode here, and I'm going to type in both of those results. Negative 3 minus the square root of 2. And I'm going to put a decimal point in there so that I can get decimal output on the TI Inspire. When I do that, I get the answer negative 4.4. Now, if I switch back, does that look like it would be about at negative 4.4? And the answer certainly is yes. If I do the same thing for the other point, I'm going to cheat a little bit. I'm going to just highlight that guy, hit enter, which means I can now edit it. So all I got to do is just change that to a plus sign. It's a lot easier than to retype it. Now I get negative 1.5 and some change. Does it look like this point would be negative 1 and a little bit more than a half? And it certainly does. And many of you have already figured out there is a way to do this graphically. If you type in this function, which I'm doing right now as you guys are watching, that should be our graph. Okay? If you want to make this graph look nice and pretty, we can view, grid, and we can throw in some grid lines. We don't have to do that. I'm going to move this equation out of the way. And we see that those ordered pairs for the intersections are pretty much in the same spots. But there's a feature of the calculator called Menu, Analyze Graph, 0 that will allow us to find them. Pick a lower bound, which just means slide this to the left of the first intersection. Hit enter. And then slide it over, and boom, lo and behold, it actually finds both of them. And those do correspond to our original answers. Now, the only problem with the TI Inspire is that as you slide this across, it'll only reveal the last one. So if you want both of them to stay on the screen, you're going to have to click enter, and then it'll stay. Try it again. Going left of the farthest point to the right, click lower bound, slide, click upper bound, and there they both are. I'm going to move him a little bit up Move this guy a little bit up so that we can see them. And then if you ever want more decimal places, you just hover over and you push the plus button, and you'll see more decimal places. Hover, make sure it's highlighted, and hit the plus button. Those do coincide with these values that we have here. Returning to our document, it says when you solve the equation f of x equal -4, what do the results for x represent graphically? State those values of x. I'm going to get rid of these things labeled on this graph. Well, I don't know, maybe do we know what that means graphically? Does it mean it crosses the x-axis? Maybe some of you are pretty confident about what it means. So I tell you what, let's just go ahead and solve for it first, and then maybe we can get an idea about what it means graphically. So instead, we are going to set this equal to -4, not 0. So our first step would be to subtract 4 over. Then we would divide by -2. And then we square root both sides. And I don't want to make a silly mistake. These are 3's. That was not intentional. So I will fix that. Now if I take the square root of 4, I would get plus or minus 2. And then if I solve for x, I'll subtract 3 over, and I have -3 plus or minus 2. Now, what I would like you to do with that, yeah, you could leave it like that, but it's kind of silly because this thing actually has 2 nice answers. -3 minus 2 is -5, and -3 plus 2 is -1. What do those mean? Well, when x is -5, the y value is indeed +4. And when x is -1, the y is -4. Well, wait a minute. We made some kind of mistake here. Let's go back and look at this. If we let the y value be -4, and I subtracted 4, that would be -8. Divide by -2, that's +4. Square rooting both sides, and then I subtract 3 over. -3 minus 2 would be -5. Well, I'm not up here. I'm down here, of course. That should be what we want, right? We wanted the y value to be -4. So, to be honest, it's not a real monumental thing that we found. We just found 2 points when x is -4. So if it asks you, what do the results mean graphically? Well, these are 2 points on f of x's graph where f of x, or the y value, is indeed -4. That's all it means. All right, set up this example here, and we can close out this first video. For f of x, solve each of the following equations. Well, guess what? We've already done those things. We're not going to formally repeat these because that's exactly what happened right here. When it said to state those values of f of x, what they were really wanting us to do is probably guesstimate what they would be. Think about what those 2 decimals were going to be. Obviously, we didn't have to think a whole lot here because those were nice y values. Okay? But in this particular case, the answer for A would certainly be this answer here. And the answer for B would be these guys. Okay? But when we get to the next video, examples 3 and 4, I think, really go into a lot more detail and show you a little bit more about what's going to be expected when you guys are working on the homework. Okay? So in summary, when you evaluate f of a, what does the result mean graphically? You're finding the y value on the graph when x is a. In summary, when you solve the equation f of x equal a, what does that result mean graphically? You're finding the x value when the y value is a. It's just the opposite. This is finding a y, and this finds an x. That's the way to think about it. All right? All right, I'm going to close this one out, and we will see you at the next video.